Good morning. So in this session, we'll be discussing about infinite series, module number 4, infinite series. So before we move on to the infinite series, let's discuss about the definitions of a sequence. So an infinite sequence or sequence is an unended succession of numbers called terms have a definite order. That is first term u1, second term u2, etc., u3, etc., up to un, such that the sequence can be written as such a sequence can be written as u1, u2, etc., un, and in sequence un n equal to 1 to infinity. So these are some examples of sequences: 1 by 2, 2 by 3, 3 by 4, 4 by 5, etc. So the nth term is n by n plus 1. 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 2 raised to n, or 1 by 2 raised to n. So the sequence 1 by 2 raised to n. 1 by 2 minus 2 by 3, 3 by 4 minus 4 by 5. It's a alternating sequence, alternative, negative, and positive. So minus 1 raised to n plus 1, n by n plus 1. 1, 3, 5, it's an odd sequence. So these are some examples of sequences. Then move on to limit of a sequence. So if a sequence un n equal to 1 to infinity tending to a limit L, then we write limit n tending to infinity un is equal to L. As n tends to infinity, un tending to some number, say limit of that sequence un. So if the limit of the sequence is finite, then the sequence is convergent, otherwise the sequence is diverges. See for examples, n by 2n plus 1 sequence n by 2n plus 1, n by 2n plus 1. Okay. So this sequence, as n tends to infinity, this sequence tending to, so take n as a common factor from the denominator, so we can cancel n. As n tends to infinity, the sequence is converges and converges to 1 by 2. Similarly, 8 minus 2n is another example of a sequence. As n tends to infinity, the sequence is diverges. As n tends to infinity, 2n tending to infinity. So the sequence, entire sequence 8 minus 2n is tending to infinity. So it's a divergent sequence. It's a converging sequence. Okay. Now next one. So we have already discussed these two examples. N by 2n plus 1. Take n as a common factor, then cancel n and 1 by 2 plus 1 by n. As n tends to infinity, 1 by n tending to 0. So the limit is equal to 1 by 2. It is converges to, the sequence is converges to 1 by 2. And this sequence is converges to minus infinity. As n tends to infinity, minus n tending to minus infinity. So the sequence is divergent, diverges to infinity. So another example show that limit n tending to n tends to infinity, n raised to 1 by n is equal to 1. So root of nth root of n. So limit n tending to infinity, nth root of n, which is equal to limit n tending to infinity, n raised to 1 by n, equal to limit n tending to infinity, e raised to 1 by n log n. So as you all know, log n. So k into log n is equal to log n raised to k. E raised to log k is equal to k. So which is effectively this e raised to 1 by n log n is equal to n raised to 1 by n. See, 1 by n log n is equal to log n raised to 1 by n. So that is e raised to log n raised to 1 by n. E raised to log x is equal to x. So e raised to log n raised to 1 by n is equal to n raised to 1 by n. So n raised to 1 by n equal to e raised to 1 by n log n. So as n tends to infinity, 1 by n tending to 0, e raised to 0 using L'Hopital rule. Using L'Hopital rule, e raised to 0, which is equal to 1. So this sequence is convergent and converges to 1. Now the topic infinite series. We'll move on to infinite series. So given a sequence n equal to 1 to infinity is an expression of the form u1 plus u2 plus u3 plus etc. un plus etc. is called an infinite series, and we'll denote it as summation n equal to 1 to infinity un. Summation n equal to 1 to infinity un. Okay. Now, sequence of partial sums. Sequence of partial sums. Consider the infinite series. Consider the infinite series. Summation n equal to 1 to infinity un. Let S1 is equal to U1, S2 is equal to U1 plus U2, first term plus second term, S3 is equal to U1 plus U2 plus U3, and so on. So on. Sn, nth partial sum. Sn is equal to U1 plus U2 plus etc. Un. Let it denoted as summation k equal to 1 to n uk. So put k is equal to 1, you will get uk1, u1, k equal to 2, that is u1 plus u2, k equal to 3, u1 plus u2 plus u3, etc. up to n, that is u1 plus u2 plus etc. up to un. Summation k equal to 1 to n uk. Now the number Sn is called nth partial sum of the series. So this Sn is called nth partial sum of the series. Now as the sequence, so S1, S2, S3, etc. Sn, this sequence converges, then the series is converges. So if S1, S2, etc. Sn is a sequence of partial sum, we'll call it as sequence of partial sums. So these are the partial sums. S1, S2, etc. Sn is called a sequence of partial sum. If the sequence of partial sum Sn converges, then the series is converges. Sn converges implies the series is converges. And if the sequence of partial sum is diverges, then the series is diverges. Now sequence of partial sum converges and converges to some limit s, then the series is converges to s. That means the sum of the series is equal to s. Sum of the series is equal to 1, s. And if the partial sum sequence of partial sum diverges, then the series is diverges. For a divergence series, the divergence series has no sum. It has no sum. Now, a particular series, a geometric series, a series of the form summation a r raised to k. K is equal to 0 to infinity a r raised to k is called a geometric series. A r raised to k, k is equal to 0, a, k equal to 1, you'll get a r, k equal to 2, a r square, a r cube, etc. a r raised to k plus etc. provided a not equal to 0. So this definition is it's a definition of a geometric series. Now a geometric series a r raised to k is converges if the ratio, common ratio, modulus of r, absolute ratio of this series is less than 1. 1. And if modulus of r is greater than 1, the series is diverges. So if the series converges, then the sum of the series is equal to a by 1 minus r. Series converges, that means if modulus of r is less than 1, then the series is converges and converges to this point, a by 1 minus r. A by 1 minus r. A is equal to the initial point, r is the ratio. Now so these are some examples. Series, so this it's a geometric series, 1 plus 1 plus 2 plus 4 plus 8 plus etc. 2 raised to k. So a is equal to 1, r is equal to 2, r is equal to 2. Common ratio is equal to 2. Initial sequence, initial point of the series, initial number of the series is equal to 1. So this series is divergent series, since the common ratio is greater than 1. Common ratio is greater than 1. So the series is divergent. Another example, a is equal to 3 by 10, r is equal to 1 by 10. R is equal to 1 by 10. So r is less than 1. So the series is convergent. So this series is convergent and converges to a by 1 minus r. A is equal to 3 by 10. So 3 by 10, a by 1 minus r. A divided by 1 minus 1 by 10. Okay. Similarly, another example, 1 by 2 minus 1 by 4 plus 1 by 8 minus 1 by 16 plus etc. minus 1 raised to k plus 1 by 1 by 2 raised to k. So a is equal to 1 by 2, r is equal to minus 1 by 2. So common ratio minus 1 by 4 divided by 1 by 2, which is equal to 1 minus 1 by 2. So the common ratio is minus 1 by 2. So the modulus of r is equal to 1 by 2. 1 by 2, which is less than 1. Series is convergent. And converges to 1 by 1 minus r. A by 1 minus r. A by 1 minus r. A is equal to 1 by 2. R is equal to minus 1 by 2. So 1 by 2 minus 1 minus minus 1 by 2. 1 by 2 divided by 1 plus 1 by 2. So 1 by 2 divided by 3 by 2. 1 by 2 divided by 3 by 2, which is equal to 2 by 3. 2 by 3, which is equal to 3. Okay. So the answer is 3. Sum of the series is equal to 3. Another one, 1, 1, 1, 1, 1, 1 plus 1 plus etc. up to infinity. A is equal to 1, r is equal to 1. Series is divergent since the common ratio is greater than or equal to 1. So which is equal to 1, the series is diverges to infinity. Similarly, alternating series of this series, alternating series with entries 1 minus 1, 1 minus 1, 1 minus 1 plus 1 minus 1 plus etc. A is equal to 1, r is equal to minus 1. Modulus of r is equal to 1. The series is diverges. Then 1 plus x square plus etc. So the series is the initial point a is equal to 1 and the common ratio r is equal to x. And this series is converges if modulus of x is less than 1 and the sum of the series is a by 1 minus x, and the series is diverges if modulus of x is greater than or equal to 1. Okay, so these are some examples. 5 by 4 raised to k. Another examples, summation k is equal to 0 to infinity 5 by 4 raised to k, which is equal to 5 by 0. K is equal to 0 implies 5 by 4 raised to 0, 5 by 4 raised to 1 plus 5 by 4 square plus etc. That is 5 plus 5 by 4 plus 5 by 4 square plus etc. A is equal to 5, R is equal to 5 by 4 divided by 5, which is equal to 1 by 4. So the series modulus of R is equal to 1 by 4, which is less than 1, implies the series is convergent and converges to A by 1 minus R. A is equal to 5, so 5 by 1 minus 1 by 4, R is equal to 1 by 4, which is equal to 5 by 4 minus 1, 3 by 4, 3 by 4, which is equal to 5 into 4, 20 divided by 3. So the sum of the series is equal to 20 by 3. Similarly, another example, summation, it's an alternating series. Summation k equal to 1 to infinity minus 3 by 4 the whole raised to k minus 1. Now put k is equal to 1, k equal to 1, the first entry minus 3 by 4 the whole raised to 0, second one minus 3 by 4 plus third one minus 3 by 4 the whole square plus minus 3 by 4 the whole cube plus etc., which is equal to 1 minus 3 by 4 plus 3 by 4 whole square minus etc. So radius R is equal to 3 by 4, 3 by 4. R is equal to minus 3 by 4. R is equal to minus 3 by 4. Modulus of R is equal to 3 by 4, which is less than 1. The series is convergent. R is equal to minus 3 by 4. Minus 3 by 4 divided by 1, which is equal to minus 3 by 4. Modulus of R is 3 by 4, which is less than 1. Series is convergent and converges to A by 1 minus R, which is equal to 1 by 1 minus 3 by 4. A equal to minus 3 by 4. So 1 by 1 plus 3 by 4, which is equal to 1 by 7 by 4 equal to 4 by 7. The series is convergent and converges to 4 by 7. Okay, now using divergence or geometric, using the geometric series, find the ratio, rational number, find the rational number represented by the repeating decimal. So write this repeating decimal using geometric series. We are going to represent this number as a p by q form, a rational number as a rational number. So the number is 0.784784784 etc. So we can write 0.784784784 etc. as 0.784 plus 0.000784 plus 0.0000784 plus etc. So this given decimal is a sum of a geometric series with, so it's a geometric series. The common ratio is equal to 0.001. Geometric series with initial point A is equal to 0.784 and the common ratio is equal to 0.001. Thus, the sum of the series, this sum, which is equal to 0.784, etc., which can be written as A by 1 minus R, which is equal to A equal to 0.784 divided by 1 by 1 minus 0.00001, which is equal to 0.784 divided by 0.999 equal to 784 divided by 999. So rational number represented by the repeating decimal. Find the rational number. So this is the rational number. 784 divided by 999. Similarly, we can do this exercise, do it as an exercise problems. Another one. In each part, find all values of x for which the series converges and find the sum of the series for those values of x. summation x raised to k. Another one 3 minus 3x by 2, 3x square by 4, etc. Now first one expand the series x raised to k, which is equal to 1 plus x square plus etc. X raised to k plus etc. The geometric series with a is equal to 1 and radius and common ratio r is equal to x converges if modulus of x is less than 1 and diverges if diverges otherwise. That means modulus of x is greater than or equal to 1, the series is diverges. If the series is converges, then converges to 1 by 1 minus x, that is a by 1 minus x, which is equal to sum of the series summation x raised to k is equal to 1 by 1 minus x, or 1 by 1 minus x expansion of 1 by 1 minus x is equal to 1 plus x square plus etc. Similarly, another one, the geometric second one, geometric series with a is equal to 3 and common ratio is equal to minus x by 2 minus x by 2, that is 3x square by 4 divided by 3x by 2, which is equal to minus x by 2. So this is converges if modulus of minus x by 2 is less than 1. Equivalently, modulus of x is less than 2. If modulus of x is less than 2, the series is convergent and converges to a by 1 minus r. A is equal to 3, 3 by 1 minus x by 2, which is equal to 6 by 2 plus x. So expansion of this series is equal to 6 by 2 plus x.